In this video, I will give you a few hints with regards to the 2016 and 2017 exam papers or the question 3s. If we look at the 2016 exam paper, there's not much I can tell you here except that I had sent a video on parallel arrays. I suggest you watch that video on parallel arrays. And secondly, there's another video on two-dimensional arrays that I have sent to you. I would also suggest that you watch this video. And these two videos put together will assist you in attempting the 2016 exam paper. In the 2017 exam paper, you are also working with a two-dimensional array. So you have to know all the techniques that I explained in the previous video on 2D arrays. And you need to know those techniques very well. However, there is one technique in that paper, in that video that I've not explained. One of the key concepts when you're working with two-dimensional arrays is to use a nested for loop. So if I've got an array that has 4 rows and 3 columns, the idea is to generate the positions 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3. And to generate these positions, you need to run a for loop R from 1 to your number of rows, which is 4, do, begin. And then you need a second loop for C, assign the value 1 to 3, which is the number of columns, do, begin. And then when we refer to our array, let's assume that this is the array ARR, and we refer to ARR RC, this very nicely generates the positions 1, 1, 1, 2, 1, 3. Setting up the loops in this way allow us to traverse the array one row at a time. However, in question 3.3, you need to be able to traverse the array column at a time. You need to go down columns as opposed to go across rows. In order to achieve that, all you simply do is swap your two for loops around. You have your column loop first. For C, assign the value 1 to 3, do begin. And then you bring in your R loop. For R, assign the value 1 to 4, begin. In this instance, when you refer to the array RC and you're doing something to it, your R value is going to be changing as the loop changes, and the C value is going to be fixed. In other words, when C is 1, then R is going to be 1, 2, 3, 4. When C becomes 2, R is going to become 1, 2, 3, 4. Thereby taking you to 1, 1, taking you to the position 1, 1, 1, 1. This is C and this is R. So I should have written it the other way around actually, so you could see it, because when we're accessing the array, it's RC. So it's taking you to the position 1, 1, 2, 1, 3, 1, 4, 1. So you're going to 1, 1, 2, 1, 3, 1, and 4, 1. If you look at the array 1, 1, 2, 1, 3, 1, and 4, 1, that helps you to come down, to traverse the array down columns as opposed to going across in rows. So that should help you for 3.3. Another example that could help you in 3.3 is that in 3.3, you need to move columns. You need to shift values from the right in your 2D array. You need to shift values from the right to the left. So in order to shift values from the right to the left, so you're shifting left. In a 1D array, you would have your array I that takes on the value, the array in front of it, which is I plus 1. So I plus 1 will be 1 ahead, and that is being shifted to 1 before. So this is the concept of how you shift in a 1D array. However, in the question 3.3, you are required to shift, but you are shifting in a 2D array. So you have to think very carefully in your 2D array, because you've got two values for your row and your column. And here you're going to have ARR 2D, and you're going to have a row and a column as well. So for one of them, you have to determine which one it is. You're going to have a variable in one of them, and let's assume you're shifting across columns. So if this is C, then if that is C, then here you're going to have C plus 1, whilst you may want to keep your R the same. Just think about how you would apply this type of concept in a 2D array. In question 3.2, the advice I could offer you there is you need to find the average. You could possibly create another array, ARR_av, and store the averages in this array. And then when you need to compare, first you'll calculate the averages, store them in the array, and then go through your 2D array again and compare them against the averages in the 1D array, which is required. These questions are a little tricky. Apply your mind and try to see how best you can solve them.